Hello, everyone. Thank you for joining us for the Skyrocket Your IoT Project with Satellite IoT webinar, where we'll discuss key lessons from forerunners. Before we get started, I'd like to say a bit about who we are. CoAP is an award-winning IoT software company that enables organizations to quickly and efficiently manage their IoT devices. We do this through interoperability and through lightweight M2M. Before we get started, I'd also like to discuss a few housekeeping items. The first is that the webinar will be recorded, and the slides and the recording will be sent after the webinar. As you have probably noticed, all of the participants are muted, but that doesn't mean that we don't want to hear what you have to say. So we encourage you to send your questions through the chat for the Q&A session that we'll have after the webinar. For today's agenda, we'll discuss the satellite IoT market, as well as different satellite options. We'll discuss IoT device management considerations, and we'll discuss an implementation use case as it relates to the performance and sensors for oil and gas networks. Our speakers today include Satya, who is a principal analyst at IoT Analytics. We'll hear from Z, who is the Senior Director of Software Development at American Innovations. And we'll hear from Olivier Carmona, who is the VP of Sales and Marketing at IoT. Satya, would you like to start?
Yeah. Today we're going to discuss on the what is the satellite IoT market looks like and what are the different satellite options are. So my name is Satya Sinha. I'm a principal analyst at IoT Analytics. I also lead the team for IoT hardware, component connectivity, and security. So let's start with basic what is satellite communication network. Despite it being used from last, I would say in 70s as well, satellite connectivity has not picked up as much as it has the potential. And one of the key reasons were the cost and the power efficiency. Currently the terrestrial network only covers 15 to 20% of the planet's surface, where satellite network provides the coverage nearly all to the Earth's surface and help accommodate to the increased IoT connectivity needs in isolated and inaccessible areas. And I think in last 4 years, we have seen a huge uprise in the demand from satellite communication, satellite IoT connectivity. And one of the key reasons is the LEO-based satellite connectivity, which has reduced the cost and the power efficiency to a certain extent. However, if we just talk about what is satellite IoT communication network, it includes three key aspects of it. One is a space segment, which includes satellite, transponder, antennas, communication equipment, which act relay stations for signal between Earth and other satellites, and also and within Earth-to-Earth communication sometime as well. Within ground segment, it includes infrastructure, equipment on Earth, ground stations, antennas, control centers, communication with satellites, and send signals, manage data flow and communication links. However, the individual, the user segment, which is basically the businesses, which is devices, sensors, gateways, and for a few of the examples we can talk about, like satellite phones, internet modem, TV receivers, and this is how the basically the satellite communication network looks like between the communication between these three elements. Now, what is IoT satellite IoT? You would say like it's only 2% of global satellite connectivity right now, but it has a huge potential to grow faster. Like the satellite IoT connectivity revenue is growing 14 times faster than traditional satellite connectivity revenue, and IoT emerging as a significant category of it. A typical satellite IoT networks comprise of 5 elements: IoT data acquisition system, satellite terminals, gateways, satellite networks, ground networks, and IoT application servers. Basically, if you look at the IoT data acquisition system, which is basically sensors, gather the data from different sources and transfer it to either directly to the terminal or the gateway or to the satellite. And also there is the satellite network consists of satellite orbiting Earth, providing coverage to the remote origins. And there are ground networks route data to appropriate destinations, and IoT application server receive, process, analyze data collected from IoT devices and data interpretation. If we look at the satellite market, as per IoT analytics, we are predicting as per IoT analytics, we are predicting it will grow from 6 million connections to 22 million connection in 2027. However, in this webinar, I will touch on the topics which will change the forecast in the market, and all of the forecasts right now which are in the market. From the revenue perspective, if we talk about the connectivity part only, the satellite connectivity part only will surpass $1 billion by 2026, and it's growing at the rate of 14% CAGR. If we talk about the type of devices, what satellite connectivity, satellite IoT connectivity has, it's basically two types of devices, which is one is indirect access mode and direct access mode. When we talk about indirect access mode, it's basically a terrestrial gateway or terminal, which connects to the other IoT sensors within the area and collect the data and then transmit it to the satellite and receive the communication. However, in the direct access mode is basically the devices itself has the capability to communicate with the satellite. And this includes like they have a module which has a capability to talk to or communicate within the satellite. We can give it from a small example. You can understand it from in an agriculture field. If there are multiple sensors, those sensors are sending data to a gateway, and that data gateway has a capability to communicate with the satellite. However, in the fleet management, if the vehicle has its own TCU connected or telematics gateway unit connected, which has a capability to send the fleet management data to the satellite. In terms of deployment, we have seen two kinds of deployment right now. One is standalone deployment and one is hybrid mode, which is basically in standalone, the devices will have only satellite connectivity and no other connectivity in that. It will only communicate to satellite and bidirectional as well. However, in the hybrid mode, the devices and gateways have the capability to not only just communicate with the satellite, but also has the capability to communicate with the terrestrial network. And this gets interesting because now it's a multi-connectivity approach where we will see the IoT devices sensor can connect to both satellite network and terrestrial network, providing flexibility and multiple connectivity option, and then it actually increases a lot of opportunity for the applications to grow. Earlier, most of the satellite basically was based on geotypes. However, recently we have seen the rise of LEO satellites. And what are the basic difference between these two we talk about? GEO has a different altitude. It lies above more than 35,000 kilometer altitude, where LEO lies between 160 to 2,000 kilometer altitude. And LEO is generally based, it's meant for low bandwidth, low power applications to easily communicate within that. And one of the interesting part of the LEO is that how it's growing much faster is one of the leveraging CubeSat technology. So it's basically makes them suitable for communication for low power devices, and it's easy to deploy. The CubeSat technology is much easier to deploy and can be scalable much faster. If we talk about a few of the examples of why the rise of LEO satellite, we have seen chipset coming into the market who has the capability to directly communicate to the satellite. We have ORG 3990, one of the chipset that has the capability directly to use the totem constellation of LEO CubeSats to implement the LEO-based connections. Same goes to from Astrocast. Astronaut S has the capability of bidirectional communication. It's a direct orbit satellite module which has the capability directly communicating to the satellite. However, the interesting things that we have seen is the hybrid satellite and terrestrial connectivity approach, where the modules and chipsets are not only capable of talking or communicating to the satellites, but also communicating with the terrestrial network. One of the key example I would say is LoRaWAN LWM2M chipset, which has a multi-connectivity approach from sub-gigahertz, SATCOM S-band and 2.4 gigahertz, which also connects with the not only satellite, but also to the LoRa network within the terrestrial network. It's one of the key applications. I would say the end-to-end supply chain tracking is one of the key applications for these kind of chipset, which actually tracks the asset from the warehouse to the delivery, to last mile delivery. So it enables to create all the connectivity technologies, to leverage all the connectivity technology to deploy this solution. Now, the interesting thing that we have seen in last 1 year is basically the rise of the end-to-end satellite communication system from a cellular side of it, and basically more of a NB-IoT over end-to-end satellite connectivity. And one of the key recent launches in last MWC in Barcelona, we have seen from Altera Semiconductor ALT1350, which has a capability of not only an NB-IoT module or LTM module, but also have a capability of a end-to-end satellite connectivity. And not only the chipset players are coming up, the module players like Sierra Valley, Stellit, Syntel, Fibocom, all announced that they are going to leverage this chipset to create a module out of it, which will have a capability of not only with LPWA module, NB-IoT module, but also have a satellite connectivity. And recently, we also seen the announcement from Qualcomm and the partnership with Skylo that they have launched modules for not LEO-based, but for GEO-based satellite connectivities, and which has a capability for both terrestrial and satellite connectivity. And Quictel is one of the first module vendors who adopted this chipset and announced the module to be launched. Just for key takeaways, if we summarize what we have understood and what are the important things, the first is the satellite IoT market is gaining traction. LEO-based satellites are the key ones that driving this growth. The hybrid satellite terrestrial connectivity is on the rise, and the partnership and the collaboration that we are seeing from terrestrial satellite network are very important. And one of the last point I would say, the most important, I would say, the entry of cellular IoT module and chipset player in the satellite IoT market, which has the capability to change all the forecasts that in the market right now have. And it will have a totally different outcome within a year. We will be able to see if this not only models have the capability to implement it, but we try to see the adoption of activation of these modules for the satellite connectivity. We will have a totally different numbers in the market that we have forecasted till now. So thanks. Yeah.
Thank you, Satya. Thank you so much for. I see that it was not easy to cope. I hope that I will have a better experience with the screen. So let me try to have one. If we go, make it okay. Okay, so let me start with, Mackenzie presented you IoT wrap, and I just want to enlighten the fact that our vision is about deploying massively devices, and satellite IoT is a way to deploy massively devices and across a very large geography. And we provide the tools that are helping those deployments to go and be really affordable, because we care about all the requests that you need to take when you get with those those large quantity of devices being deployed. So course, we care about firmware update. We care about managing millions of events coming up. We care about performing operations on devices and making them easily automated. We care about also simplifying the installation, and we care about helping you delegate operations to your customers and customers of your customers and so on. For that, we built a solution which is extremely efficient, but extremely efficient to reduce your cost, reduce your operating cost, reduce also your capital expenditures by simplifying the device that can work on those solutions by really reducing your footprint and also increasing the battery life. So that's where really we help in smart metering, in street lighting, in container tracking. If we go into the details of what is our value proposition, it is in two parts. It's a code, a C code that we provide for devices, embedded source code called a software development kit called Iowa. And we have in the cloud a platform which is particularly efficient, which is called Alaska. And that allows you to be able to manage your device, but also get your data through and orchestrate that data at the pace that you want or that the device wants. If we look now to what we have learned with satellite customers, such as American Innovations, we've learned a lot about many of the things that are required to go through an efficient implementation. I will go through those generic elements, those generic tips, and all of those tips are already included in our product so that you can make it very efficiently. So let's go one by one. So first of all, and Z will insist on that as well, it's very important to use an extremely compact data format. It happens that in the very latest implementation of Lightweight M2M, Lightweight M2M version 1.2, a model, data model, well, data compression or the CBOR, Lightweight M2M CBOR has been introduced that allows to be extremely efficient in terms of footprint, and that's extremely important when your data consumption is limited. We also provided other solutions such as the way for you to store your context to save battery. It may look a dumb thing to do that, but it's not so easy to saving and restoring from the full stack context to persistent storage. It's much harder than it seems. And what we have been doing is allow for zero power usage for extended period of time, and that's where you really gain some power saving. It's also a very simple thing also, which is to care about storing the notification when your signal is not efficient. So it's very important to be able to store those notifications so that you don't lose them and you don't try to make use of it because you have a bad connection. So you need to be able to store those data in non-volatile memory. So that's one also important aspect. Another important aspect is to use the appropriate protocol. So on a satellite communication, you cannot sustain permanent connection, and the latency is measured in tens of seconds and more than that. So you need to rely on an asynchronous protocol. MQTT TLS is a synchronous protocol that requires to maintain a connection, and hence it's extremely unpredictable to know the number of reconnections and the latency that can happen. You need to use an unpredictable number of keep alive messages to keep the connection open. So it's extremely inefficient, and you need to use a synchronous protocol, and CoAP is offering such a good solution here. You need also to use an advanced COAP stack that allows you to manage all the aspects of your release assistant indicator. Release assistant indicator is an indicator that gives you an important information about whether you need to wait or not. It's important to not wait for nothing if you don't have anything that will come back from your satellite connection. You need also to consider the time constraints that are related to your CoAP communication. You need to be able to use as much as of the features that are available in your communication, and you need also to consider the maximum transmission unit limitation that are not necessarily the same according to the communication. You need also to use a compact security solution. There is a solution that has been implemented in Lightweight M2M, but it's an Internet Engineering Task Force solution, which is OSCORE. OSCORE is 30% more efficient than DTLS. It can be either used as is, or it could be used as a complement to DTLS if you want an extra security level. But it's a good solution if you are really in a need for an extremely constrained security. You need also to use DTLS connection identifiers. Connection identifiers are tokens that helps you avoid doing a handshake. So if you look at the number of transactions that are needed to achieve an MQTT TCP/TLS communication, and if you want to do a resumption according to the TCP/TLS, you can see on the left that the difference is huge compared to what you can do with CoAP in particular if you use the connection ID token. If we look also at what Lightweight M2M implements on top of CoAP over UDP, it's a solution that helps you not only provide something interoperable, but mostly it also helps you define in a very simple, in a very easy way, an automated way of diagnosing your devices, remote controlling them, make firmware updates or delta firmware update if you don't have so much bandwidth, and also be able to define access control to device, defines also automatic installation procedures. So that everything is available in a very simple way, and it really fastens your time to market in developing your application without having to care so much about testing all of those solutions, because they come from an existing package. You also need to look into the really details about the way you implement your retransmission rates. According to your communication, that will be extremely important to look into those details, because you will be able to save a lot of your operations and of your energy in doing so. You need also to use the best way to talk to your device. Lightweight M2M allows you to ever ask from the server to the device, and that's the natural read mode. You can also ask the device to tell you, so the device is mastering the communication and telling the server when and only when it can send information based on his own battery request, his own battery level. Or you can have the server ask and observe operation, and ask every hour, every minutes, every whatever, and send that information or buffer it according to the situation that the device is expecting. So there are multiple ways here. You need to optimize at its best, and it's important to remember that the device can take the hand here in Lightweight M2M. It's not only the server driving the communication. It's also very important to use composite operations. Composite operations are a way for you to avoid, if you look on the right, the device not supporting composite operations, have to go and make 4 operations to read each of the objects that are available on the device, while on the other device, which is on the left, is able to provide you in one operation, will be able to read the 4 objects at the same time. So that's very important for saving a number of transmission, which is an important also item for your battery consumption. It's also very important to use the latest Lightweight M2M, Lightweight M2M 1.2 compact device registration. In 1.1, a lot of updates have been brought. 1.2 brought even more compact registration updates. It's very important for you to avoid the case where in 1.0 you could go back to Bootstrap mode and kill completely your I would say your way of communicating with the device, because you will have to go into a Bootstrap operation, restarting from zero, basically. You can also use the latest implementation of lightweight M2M Compact Bootstrap. So it's only one-time operation during the life of a device, but the lightweight M2M Compact Bootstrap is basically implementing the Bootstrap in one single operation. Bootstrap can be used at the installation of a device. It can be used also to swap your certificate key. It can be used for multiple applications, actually, not only for the initial Bootstrap. It's important to also think about it. So all those features are available from our solutions. They have been the fruit of our experience. We brought some of those elements to the specification. We brought into OMA SpecWorks those elements to lightweight M2M specification. We brought some of those features into the Internet Engineering Task Force, into some of the CoAP or OSCORE implementations, to RFC, sorry. And so that's very important experience that we have been able to bring. And we can guarantee you that you can do those tests, those implementation in 5 days. So you can really go and test and try our solutions for free, actually, and see that you can, in a few days, in a few hours, be able to test and bring up your devices and implement a lot of features, not only just communicating, but also being able to do your firmware update, being able to conduct remote control your devices, and using standard objects. Thank you for listening to me. I'll let you the floor, Zim.
Hi, everyone. Welcome to the implementation use case part of this webinar. My name is Z McLean. I'm with American Innovations, Director of Software and R&D. And so what you're seeing here on the first slide is a picture of a rectifier. We'll talk more about what a rectifier is later. But on top of the rectifier, there's this plastic dome. That is where the satellite modem lives, and that is the RM510S satellite remote monitoring unit that was launched last month, June of 2023. All right, so we'll start with introduction to American Innovations. We'll talk a little bit about corrosion, and then we'll talk about cathodic protection for oil and gas pipelines. Then we'll go to the problem statement and our solution, and our satellite RM510S remote monitoring unit, which uses Iowa and the Iridium satellite network. Then we'll talk a little bit more about the Iridium network and benefits of using IROP's Iowa client. So American Innovations, we are an industry leader in providing field data collection, remote monitoring, and pipeline compliance solutions. We have a complete suite of hardware, software to cover all of that. So we have survey equipment on one side of our business, and we have rugged tablets. We have mobile applications that collect data from surveys. And then on the other side of our business, we have the RMUs, which are the remote monitoring units that collect data, and then everything goes to our web portal. And then from our web portal, it flows into our client compliance solution. So we have a complete ecosystem for everything that our clients need, from the field all the way to compliance. We have over 3 decades of innovation. Now, the satellite is not new for American Innovations. We have had satellite products in the past decade. The product we're going to talk about today is the next generation satellite product that uses the Iridium network. So here, again, in this picture, you're seeing a field technician walking with 2 canes. Right, so this field technician is performing a continuous interval survey, and he's walking with those canes, which are actually electrodes, over a pipeline. So American Innovations, we provide satellite and cellular end-to-end solutions. We also won the MP Corrosion Innovation of the Year Award this year as well. And we'll touch a little bit more on a continuous interval survey later on.
Try just to click on the image. Yes.
Yeah. So let's start with the super quick tutorial on corrosion. So if you recall from your days in school where you talk about batteries and how batteries work, is you have a cathode and you have an anode and you have an electrolyte. And as the anode dissolves into the electrolyte is where how you get power for a load in a battery. Similarly, when without any protection, when a metal pipe is inside the soil, without any cathodic protection, the metal pipe acts as an anode. The soil has a pH, it acts as an electrolyte, and then the anode slowly dissolves into the electrolyte, which in this case is the soil, and that is corrosion on a pipe that's in the soil. So how do we prevent that from happening to a pipe that's underground? Well, that is called cathodic protection. So what we do is in the earlier pictures you saw the RM510 installed on a rectifier. So here there's a rectifier. The rectifier is getting power from the electric pole, and it is connected to an anode, which is in the soil and also connected to the pipe. So what the rectifier does is it forces the pipe to not be an anode, but be a cathode so that it's not dissolving into the soil. Instead, the sacrificial anode, which you see vertically going down, the CoAP breeze, is what erodes into the soil. So this way, you're protecting the pipe from corrosion. So that is what is called cathodic protection. So in oil and gas, cathodic protection is extremely important. It's used in fuel pipelines, storage tanks, offshore platforms, oil well casings. Now, corrosion is a slow process. So it can take from months to years for a pipe to corrode to a point where it is breached. But that breach has devastating consequences when it's not monitored and surveyed, when the pipes are not monitored and surveyed. I mean, we're seeing in the last 10 years, we've seen a lot, these pipes, they're going through rural areas, and then 10 years later, as the population increases, those rural areas become residential areas. So now your risk on that section of the pipe has gone up because any breach in that pipe can, if it's a rural area, you're affecting the environment. And then if it's a residential area, there's threat to life, right? So American Innovations helps our customers protect our critical energy infrastructure. Now, features of the RM510S, which is our rectifier satellite remote monitoring unit. Its core features are it reports weekly. So it collects measurements and reports via satellite weekly. That those measurements go to the website. It also has the capability of sending alarms on AC and DC voltages when they're out of range. It also reports when there's a power loss. So in the previous slide where you saw that the rectifier gets its power from the pole, if there's a power outage, the RM510 has a battery in it. It can detect a power outage and notify our clients as well. Then it also has the capability of performing interruption and verification. This so when in the earlier slide where you saw a field tech walking with electrodes on top of the pipe. So when they're doing that survey, they need the rectifier to be interrupting, and the RM510 as remote monitoring unit can also set interruption schedules, and our customers can do that directly on the web. It also does instant off measurements, which basically is that we want to see what the voltages look like on the pipe when there is no cathodic protection. So it's able to take instant off measurements as well. Another important thing, which is not listed here, is that it also supports readings on demand, which means you can go, or customers can go to Bullhorn Web, which is our web portal, and send a message to the ARM510S satellite remote monitoring unit to take fresh measurements and send them. So it has a two-way communication with our website. The problem statement is pipelines go, as you can imagine, they go to lots of remote areas on the planet where there is no cellular coverage because there's no population, just the pipelines. So it's not, there's no advantage for cell companies to, cover those areas. And sometimes, even if they do cover it out there, the cellular coverage is very spotty. So that's a problem statement for a satellite. Now on satellite, we're also very conscious of data usage because data usage on satellite is expensive, and American Innovations would like to present a plan to its customers where they don't have to, where customers don't have to worry about overages. So our solution to that problem, it was using lightweight M2M 1.2 protocol. We also use 1.1, and we use the Iridium short burst data network, and we use IOTEROPS Iowa lightweight M2M client, which supports both lightweight M2M 1.1 and 1.2. This is our communication path, simplified, of course. Here at the bottom, you have the ARM510S, and it's a two-way communication. So it talks to the satellite. This is an Iridium satellite. From the Iridium satellite, our data goes to the Iridium gateway, and from there it goes to Amazon queues. And from the Amazon queues, it is dequeued by our lightweight M2M server. And then that data reaches our Azure IoT Hub and Bullhorn Web. And similarly, you can, when you do a reading on demand, the data is flowing the other way, then it's going from Bullhorn Web to Amazon queues to Iridium gateway to the satellite, and then our satellite remote monitoring unit. This is a brief on the Iridium satellite network. The network has 66 Iridium Next satellites. They are about 485 miles above the Earth's surface. It's a LEO constellation, which means they're low Earth orbit. These satellites form 6 rings around the planet, and each of those rings has like 11 satellites. And they travel at an incredible speed of 17,000 miles per hour. So this slide is specifically there so that I can show you, our remote monitoring unit down there is installed on the ground, and these Iridium satellites are continuously moving over, and they're moving in this pattern. So if you go to the right, you'll see that the satellite is coming up. We have a low RSSI detected by the Iridium modem in the remote monitoring unit. As the satellite moves up, you get better RSSI and better transmission. So we're able to transmit. When it's right above the RMU, the RSSI is actually great. We're still able to transmit. When it goes further down, we're still able to transmit. But when it sunsets is when you lose the RSSI. It goes from 0 to 1. And then we wait for the next satellite to come around for sending or receiving packets. Here, what I'm showing is that this is a pretty robust system. Even with obstructions, this system with the Iridium satellite network works great. So you can see that the RMU is not able to see the satellite until it comes right above. And then when it does, it gets good RSSI and it's able to communicate. So even with that short window, the remote monitoring unit is able to send and receive data. It might take a little bit longer because you have to wait for the satellite to get at the right angle, but as long as you have some sky, you're able to communicate. Now, the advantage for using the Iowa lightweight M2M client was definitely one of the big ones was time to market. It took us about 2 months for our firmware team to start to upgrade to Iowa because we wanted to take advantage of the lightweight M2M 1.1 and 1.2 specifications. Iowa is light and easy to integrate. It has a small code base. The impact to our binary was negligible. I also want to mention here that, we had really good support from IOT during our integration phase, which also helped us accelerate the integration. And also the one big advantage of using Iowa is its small memory footprint. So when you have small battery operated IoT devices, you don't have a lot of memory on those devices. So Iowa helped us save some of that memory so they can be used for other processes. Now, of course, data optimization is a very big thing in satellite communication, and lightweight M2M 1.1 and 1.2 helped us out there. We were able to switch to using composite reads and composite writes and methods like send only, where you don't care about a reply, you just want to send data. So using those methods compressed the amount of data that we used. We also use data compression that comes with the specifications for 1.1 and 1.2. Right now we're using SendML CBOR. When our lightweight M2M servers upgraded to use lightweight M2M 1.2, we will switch to new CBOR. As you saw earlier in Olivier's slide, there are opportunities for data savings using the new CBOR as well. So I hope this helped you see the possibilities for your business as well, and how to integrate lightweight M2M IoT devices using satellite for your solutions. Thank you.
Thank you so much, Dee, for the presentation. I'd like first to say to Austin Co that yes, the presentation data will be available to all the attendees, as well as the video of the recording. I'd like to jump to the question and answers. So going back to your presentation, Satya, there was a question to you about that there was said 22,000 million subs in 2027. And there is a question about what is the estimated volume of 3GPP based satellite subscribers.
Yeah, so 22.5 million includes, yes, SATCOM, LoRa, and 3GPP based numbers as the connections. However, right now, I think it's too early to talk about the 3GPP volumes, because we can give you the details of the how much shipment will be capable of satellite connectivity. But the question is not just about how much chipsets are capable, but how many of them are actually connecting to the satellite. So active connections we are talking about. So in September, IoT Analytics is releasing the satellite IoT tracker, where we will deep dive into all the categories of satellite connectivity, and we will talk about the shipment of the chipset which are satellite capable, and also the connection forecast as well.
Thank you, Satya. We have a question from Mitsuya for you, Z, about the difference between implementing a solution over cellular compared to satellite communication.
Yeah, so we came up with our cellular solution first using lightweight M2M. And there we didn't really pay a lot of attention to how we were communicating because there's lots of bandwidth. But when we started working on our satellite solution, we had to pay more attention to data usage and what was more efficient on satellite. So our solutions actually we had to diverge from what we were doing on cellular for SAT, and then the same things need to be implemented on the lightweight M2M server side to be able to use more optimized methods for data. So that was the big difference there. The second thing is latency. So in Excel network, there's very low latency. You were able to communicate faster, of course, but with higher latency on satellite, we had to rely on asynchronous communication to get our data back and forth.
Thank you, Z. I'd like to mention also that here it's a direct mode, as Satya explained before. So this is a direct communication between the RMU device to the cloud. We have been also working in different configuration at IoT Europe, also with TrackSense container trackers, where it's an indirect mode where a gateway is used on board of a boat to send information to a container tracker, and both solutions, whether American Innovation or TrackSense, are requiring to have a very strong, compact communication. And that's one of the key item for that. There is a question from Mark about the type of IP-based transport. Mark wants a confirmation that this is an IP-based transport, and is it TCP or UDP? Z.
Yeah, so our lightweight M2M solution for cellular, we did use UDP, but for the satellite with Iridium, we are not using UDP. So it's secure communication between the Iridium modem and the Iridium satellite, and then the packets at this point they're still on the Iridium network, so they're not on an IP-based network. And the packets go to the satellite. The satellite acts as a mesh server. It may transmit that packet to another satellite, which is closer to the base station. And then the packet goes to the Iridium gateway. And from the Iridium gateway, it goes to AWS-Q. So all the way from the RMU to the AWS-Q, these packets are using the Iridium network and not an IP-based network. Now, from the Iridium-Q, when the packets are dequeued and they go into our lightweight M2M server, from then onwards, the communication is IP. But while it's in the Iridium network, it is not an IP-based system. So the queues, the AWS queues are what takes the packet from the Iridium network and puts it on the internet, so an IP-based system.
Thank you, Z. A lot of questions for you. Austin is asking what's the frequency for the satellite communication, and if you can provide more information on the manufacturer of the RF module and the cost of the module. But you're not forced to answer, of course.
Yeah. So the cost, I do not have the cost of the module, but we are using the Iridium module because we're talking to the Iridium network. So the module we buy it from Iridium. Now, as far as the frequency, we have in an open area, our devices are able to communicate every 5 minutes. Not a problem, but like I showed in one of the slides, if you have obstructions, then your frequency will change. Maybe you'll be able to talk every 10 minutes, 15 minutes, or 20 minutes, depending on how many obstructions you have around the Iridium modem.
I think that Austin's question was about the frequency of communication. So in Hertz, I'm assuming, but I think it's Iridium data, right? So.
Yeah, so what's the frequency for the satellite? I mean, we were looking for the satellite every 30 seconds. If the RMU is ready to send a message, it's looking for the satellite every 30 seconds. And then when it finds the satellite with a good RSSI, it will transmit. I'm not sure if that answers Austin's question.
Yes, is it answering your questions, Austin? Yeah, there is a. Not sure, but we have a question from Michele. What is the estimated data rate, and is it bidirectional? I think we had I think it's bidirectional, but I let you the floor, Z.
Yeah, so yeah, it is bidirectional. The communication can be initiated by the remote monitoring unit, and it can also be initiated from our web portal, which is Bullhorn Web. The data rate, it depends. The data rate, of course, depends on how much data you're transmitting and how often you're transmitting. All right. In our case, we're transmitting measurements. So you know, it's numbers that we're transmitting. Our typical transmission is once a week, unless, you know, the device has an alarm that it needs to report and so on. So it really depends on the particular application.
And I think that there was a question. The question from Austin was probably whether it was you were using L band or K band or Ka bands. I think it was more on the band itself.
Oh, I see. Yeah, and I actually don't know. We use the Iridium modem, and then what the modem uses to talk to the Iridium satellite, I don't know what that is.
Yeah, I know that they use those three bands between 1 to 2 gigahertz, the L band, or the K band from 8 gigahertz to 26 gigahertz, or the Ka band from 26 to 40 gigahertz, but I don't know which one is used here. Is there any other? Yes, there is more questions. What make, so a question from Mitsuya, what make a decision to use communication technology between SATCOM, LoRa, and 3GPP? Is proper SATCOM switching to 3GPP based or LoRa based technology? Would you like to answer that question, Z or Satya? Satya, maybe you want to give a shot?
I'm trying to understand this. So no, I don't think the SATCOM proprietary is switching to 3GPP based technology. 3GPP based is totally new technology, and even LoRa based LEO satellite is totally a new technology. It has nothing to do with the proprietary SATCOM. If it seems of market adoption, if you're gonna talk about, so yes, these new technologies are enabling the adoptions. First option to go with the based on their application to require to go with the LoRa or now from 3GPP aspect as well, where the prices of the modules and chipsets will be much lower and it's easy to scale compared to a SATCOM based proprietary SATCOM based approach, which were the prices of modules were high. So the technology is not changing, totally three different technologies, but it's just the implementation and the scalability will drive the adoption of more and more. Be able to see the LoRa based satellite technology and 3GPP based satellite technology.
I think it answers the question from Mitsuya-san. Michele is correcting slightly his question. He was looking for the maximum data rate in kilobyte per second. So not the data rate that you are observing, but the maximum data rate that you can expect.
Yeah, I do not know what the maximum data rate is that the the Iridium satellite with the Iridium modem supports. The amount of data an IoT device typically sends is really small. We do not do firmware update over the air for our satellite units because of data usage. So we haven't run into any constraint, but I don't know what the max is. I do know that there is a block size that you have to adhere to, which is about 320 bytes per block. So if it's anything that's bigger than that, you have to break it up into multiple blocks.
Thank you. I think that there is no more questions at this stage. So I'd like to thank you very much, Satya, V, for your presentation and your work. It was a pleasure to host you. I'd like also to remember to the participants that they will be given access to the video of video recording of this presentation, that you will be also be provided also with a presentation of this material. And if you want also, you can send this information to third parties. They will be able to access the video recording and the presentation material. So I'd like to thank you all. Thank you so much. And I wish you an excellent day moving forward.